Example 5 of our quotient rule. Here we have two trig functions, sine of x over 1 minus cosine x. So as we try to apply the quotient rule, we're going to do low d high minus high d low over denominator squared. And that's what we're going to look at here. Low d high, derivative of sine is cosine, minus high d low. The derivative of this is really just the derivative of negative cosine, which is positive sine, over the denominator squared. On the next line, what I did was I distributed this cosine, so I get cosine x minus cosine squared x, and this product here would be minus sine squared x over 1 minus cosine squared x. From here, I decided that I could pull a negative out from these two terms. So I pull a negative out, put those in parentheses, it leaves me with the cosine squared plus sine squared. And as we've already saw in these examples, sine squared x plus cosine squared x is a Pythagorean identity for trig. That really goes to 1. And so then I was able to write this as cosine x minus 1 over 1 minus cosine x quantity squared. Right terms, opposite signs. So what I could do, I could pull out a negative 1, pull out a negative 1 there, and that would allow me to cancel one of these factors. And so you may not follow from here to here. What I did was I went negative cosine x plus 1 over 1 minus cosine x quantity squared. Now, negative cosine x plus 1 is the same as 1 minus cosine x. So I was able to cancel one of those factors. That's how it left me with 1 over 1 minus cosine x. And then I said, just as an equivalent statement, I could apply that negative 1 down to the bottom. I can move it down, it's just a fraction, and call this 1 over positive cosine x minus 1. And as we've stated before, calculus students are expected to be able to look at and recognize equivalent statements. These are equivalent statements here. That was example 5 for the quotient rule.